The Science Museum in London is being prepared for a most peculiar event. Here, live in front of hundreds of people, an alien world is about to be explored.
Oh, God.
Keep going, and keep going.
It will be scrutinized and probed. Our guts. A mysterious place of writhing tubes, corrosive acid, pulsating muscles. Their dirty work, normally invisible, is about to be laid bare in all its gruesome detail. And the guinea pig for this? Well, that'll be me. During my medical training, and more recently as a television presenter, I have taken part in some pretty bizarre and painful experiments, but nothing quite like this. There's a new attraction at the Science Museum today. For one day only, my intestines are going on display. I want to do this because I'm curious. The digestive system is something we all have, but know so little about. My guide is gut expert Dr Mark McAlendon. Hi, Mark.
Hi, Michael. Nice to meet you.
And you. It's a very theatrical setting, isn't it? Yeah.
It is. It's not a conventional medical environment, but there we go.
I think we're going to have some fun today.
I think so too.
Right, so what happens next?
OK. So first of all, stick this one in.
OK.
Ooh, cold.
Mark is going to monitor me as I eat a typical day's food. And we'll all watch what happens as it goes on its merry way. These lucky visitors will see parts of me that have never been seen before.
Perhaps I'll ask you to put that over your head.
Sure. We're using the very latest technology. A miniature camera inside a pill. It will, hopefully, travel through me and transmit live pictures from the depths of my guts. And as it goes, I'm going to take part in a number of tests. It's a leap into the unknown. We'll be trying things today that few have tried before.
Lie down. We'll just do your pulse and blood pressure.
Oh, elegant chaise longue here.
There is one, which is just as well. Which means you're as fit as a fiddle, fit to go.
Marvellous. Fit to swallow pills. Once swallowed, I'll have no control of the camera. The murky world of my intestines is a law unto itself. And how long it will take the camera to work its way through is anybody's guess.
16 hours.
30 hours,
2 days.
Depends on what you've eaten, really, isn't it?
24 hours.
12 hours.
A few days, 1 day.
2 days?
2 hours?
Food can take up to 3 days to travel through the gut. But last night, I drank 4 litres of laxative to clear the way. So I'm expecting my camera to travel rather more quickly than that.
OK, Michael, well, I'll give you the pill camera. And if you'd like to take it out of its holder, if I can actually manage that.
Right, OK. This pill houses a mini film crew, complete with lights and camera. It will take pictures 3 times a second and transmit them to screens here in the Science Museum via sensors on my body.
So, Michael, ready when you are.
OK.
You pop that into your mouth.
OK.
A few gentle swips of water. Has it gone?
It's gone. It's gone on its long journey. I can't get it back. It's too late. My first feeling is one of relief. The camera is clearly working as it slides down the back of my throat and heads towards my stomach. It's very funny. Propelling the camera down are powerful muscles that line my gullet or esophagus.
Anytime you swallow food, the esophagus will be able to tell that there's a force on its wall, and that initiates the process of contraction of the muscle to try and push it further down.
It's really quite magical.
So this black hole here, soon you'll see the capsule passing into the stomach. Here it goes.
Ooh, there it goes. Down here, it's a cavernous, alien landscape. And you can see some white blobs of porridge I ate for breakfast. But what's really striking is there is so much pulsing and throbbing movement going on. It's something we're normally completely unaware of, but it's happening all the time and throughout our digestive system. Our guts are a tireless machine. And I spent a morning in the run-up to this exhibition having some scans to find out just how the different parts work together. I've seen my heart beating, my brain buzzing, but I have never seen my guts in action. Well, lucky me, today I get that chance. Here at University College Hospital, radiologist Stuart Taylor and his team are using a stop-motion technique to capture the unconscious movement involved in a journey through our guts. To get the best possible images, I'm knocking back a rather disgusting drink.
So this liquid's got a special sugar in, which isn't absorbed by your body. So when we do the scanner, we'll be able to see the inside of the bowel very well and how the bowel works and moves.
It's an acquired taste, isn't
it? It is. Probably not something you would choose to drink every day, but hopefully not too bad.
Michael, I'm going to start few breathwork scans now, okay? Breathe in and hold your breath.
As I hold my breath, the team takes a series of high-speed images.
This is the last scan.
These will be stitched together to form a 20-second film of my guts in action.
All finished, well done.
This technique is normally used to diagnose disorders affecting movement in the gut. It's absolutely fascinating. What surprises me is just how much movement there is in here. You know, it really is a dance. I was lying completely still in the scanner, but this slice through my guts shows they were anything but. Any food passing through my digestive system takes the same route, through this pulsating, writhing, continuous tube. Down my gullet and into my stomach. Then into my small intestine, or small bowel. Next stop, it's the large intestine, otherwise known as the colon. And then it's out the other end. It's this constant movement throughout our guts that enables our bodies to transform food into the nutrients that keep us alive. here at the Science Museum, the camera has so far travelled down my gullet and into my stomach, where it's transmitting live pictures to the visitors. Now it's time for some food to start its journey through my guts. I'm going to test the powers of my digestive system by feeding it a substantial meal that will really fill my stomach.
OK, bring on the food. Hooray! I have been waiting a long time for this. Thank you. So this is the first green thing I've seen for about 3 days.
As the food reaches my stomach, powerful gastric juices are released. These juices contain hydrochloric acid and digestive enzymes. And over the next few hours, they transform my food.
So this is my stomach having eaten, and the picture's very different to when it was empty, isn't it?
Yes, it shows what a fantastic job the stomach can do. It's really done a blenderizer job here.
I think I saw something which was probably the beetroot going past as well. That sort of red thing. Oh, there's a great big leaf.
There's a leaf there.
And it looks like a bit of beetroot over there on the top, bit pinky stuff.
A bit pinky there?
Yeah.
Yes, the leaves will be a lot of fibrous material, which is much more difficult to digest, so that might stay that way for a little bit longer, as the white bits are probably the chips, so they're now dissolving in the gastric acid, so that's more of a mash of stuff.
What happened to the steak, then?
It's interesting that we don't see lumps of meat. You would think that that would be the case, but the meat will be broken down into fibrous material by the action of chewing, and then will be acted on by gastric enzymes and the gastric acid to such an extent that you can't actually recognise the meat in the stomach. You can recognise the plant material and some of the carbohydrate, the starchy material, but no lumps of meat there.
With a big meal of steak and chips inside me, my stomach has expanded. But by how much?
What, in size, yeah?
You answer, darling. I haven't a clue.
I think it can get really big.
Probably double in size. Like this size.
That's too big.
My fist.
Small rugby ball.
Medium-sized melon.
I reckon a good.
I think 2 litres.
She's right. The average human stomach can expand from the size of a small apple when it's empty to about 2 litres when full. That's a 40-fold increase. And it's now clear that this expandable bag of muscle has more subtle and powerful ways to influence how and when we eat than was ever previously imagined. Father of 4, Bob Lackenpal, rarely feels full, no matter what he eats.
No, I don't want salad. About 9, 10 o'clock, I have my first breakfast. A couple of toasts, a bowl of cornflakes. Lunchtime is normally a couple of chapatis with some chicken or vegetable. After my lunch, if I'm feeling more hungry, I just get a bowl of cornflakes or Weetabix. In the evening, I get some chips, a burger, and later on, a chapati. No, that's enough. If I'm feeling a bit peckish, buy a big crisp bag and just munch away. I just can't get full. I want to eat everything.
Bob is almost 20 stone, and being so overweight has had serious consequences. 6 years ago, he had a major health scare.
I was at home, I was lying down, and next to me I'm getting pain in my jaw and in my arm. So I thought, something's wrong, let me just drive to the hospital. So I drove there and they said, you're having a heart attack. I was about 28 at the time, young, getting a heart attack. I was just devastated, yeah.
Bob tried going on a diet, but couldn't lose enough weight. He and his doctors have decided to take more drastic action. Bob is about to have a gastric bypass operation. The size of his stomach will be radically reduced.
Now, what are you going to dream about today?
Getting thinner.
His doctors expect the operation to have a dramatic effect on his appetite. For Bob and his family, it's the best hope of bringing about the health changes that he desperately needs.
Okay, dizzy coming?
Yeah.
Okay. Take 3 slow, deep breaths. At the end of the 3rd one, things will be much better. Drifting gently off to sleep. Good.
I'm here at Charing Cross Hospital to watch Bob's surgery. His surgeon is leading bariatric consultant, Mr. Ahmed Ahmed.
All right. John, are we ready to start?
He will operate on Bob using the latest techniques in keyhole surgery.
So I've gone through the skin, and the yellow stuff there is fat. We're going to go through the fat and then through the abdominal wall muscle there. First quick peek inside, we're going to see that all the yellow stuff here you see is fat.
The first stage of the operation is to shrink the size of the stomach.
That little pale pink organ coming up, and that's your stomach right there.
And you're essentially going to reduce the size of that, eh?
Yes, absolutely.
By what sort of amount?
We'll probably make it about 1/10 of its normal size.
10% of what it is at the moment. Wow, that's quite radical, isn't it?
Yes. The total volume is going to be about 20 mils, which is about 3 or 4 tablespoons.
So 90% of the stomach will just be kind of left there inactive, will it?
Exactly. It's still going to have its blood supply, and it's still going to make, gastric juices, but it'll never see food again.
And, surprisingly enough, it's not just Bob's stomach they're affecting.
Now, you might think that just by reducing the size of the stomach, that's how it's going to sort out Bob's problems, because smaller stomach, you eat less, it's sort of straightforward. But actually, the mechanism by which it works is completely different. And it's only relatively recently that they've discovered why doing gastric bypass is so effective.
The modern thinking actually is that by making a smaller stomach, you're actually inducing the changes in various chemical messengers, which in turn affect hunger levels and fullness levels, which in turn cause the weight loss.
So, as well as reducing the size of Bob's stomach, the point of the operation is to change the levels of certain gut hormones. These chemical messengers are released by the gut in response to food and tell the brain when to eat or stop eating. One of the hormones, ghrelin, makes you feel hungry.
We think that ghrelin is actually being produced from this part of the stomach up here.
Right.
This fundus. This is called the fundus of the stomach, and this is where all the cells that produce ghrelin are sort of based. Now, what we think we're doing is we're actually separating that part of the stomach completely from ever seeing food. So the food will never touch those cells that make the ghrelin.
Once they're isolated, the ghrelin cells no longer function normally. Hormone production will be reduced, and Bob should feel less hungry.
Extraordinary, isn't it? That little area of the stomach could be responsible for how hungry you feel.
The next stage of the operation is to reattach Bob's smaller stomach back to his intestine.
Good, let go, thanks.
From now on, it will be right next to the part of his intestine that produces the gut hormone PYY that makes him feel full.
How long does food normally take to get there?
This is probably about 20, 30 minutes, I would imagine.
Right. So instead of taking, say, 20 minutes for your brain to get the message, you're full, stop eating, it might take, what, 5 minutes? Or?
Yeah, about 5 minutes.
Mr. Ahmed believes the operation will have an immediate impact on Bob's appetite.
Patients that would normally eat 3 or 4 meals throughout a day eat maybe just 1 or 2 meals after surgery. And when they do eat, they eat really small portions through, side plates or children's portions, because they just don't feel like eating the same amounts as they were before. And they're happy. It's not like something that's imposed on them. They actually are very satisfied.
What I find really astonishing about this operation is that the effects are so profound and widespread, because in essence what he's doing is he's just sort of making the stomach smaller, connecting the bits, and yet the effect on Bob will be enormous. We think that the brain rules our decision-making process, but it's pretty clear from this that our stomach has a very, very profound effect on how we behave.
Six weeks after surgery, Bob is certainly slimmer than he once was.
Since the operation, I have lost 3 stones. I was 20 stones. Yeah, I've been losing weight, and all my clothes are all loose.
Crucially, Bob's urge to eat lots of fatty foods has gone.
I had a bite of a burger, I couldn't swallow it, so I'm keeping to my diet. I only drink a cup of soup and I'm full. I'm happy with that, and I can stick with that. It's just great. Family is happy, I'm happy. Can't wait to lose more weight.
The camera has now been travelling inside me for over 4 hours. It's made its way through the acidic and forbidding world of my stomach and embarked on the longest part of its journey, the small intestine or small bowel. Over the next few hours, as it travels along this tube, my steak and chips will be broken down, absorbed, and transformed into the energy needed to run my body. As for me, I'm taking it easy.
Ooh, it's amazing how contented you feel after a nice big meal. Also how tired and slothful.
And I suppose it's no surprise I'm tired. There's a frenzy of digestion going on inside me. As I snooze, the tight folds on the wall of the small intestine are mixing and churning my mushed-up food in a corkscrew motion. Digestive enzymes from the pancreas and gallbladder flood the area. These enzymes induce chemical reactions, which break the food down into nutrients that my body can readily absorb. The walls of my small intestine look a bit like a fluffy towel. And they are there to aid absorption.
So on the folds here, on the folds of the small bowel, you can see the finger-like projections of the small bowel lining, which are called villi, and what they do is to increase the surface area of the small bowel hugely.
What sort of surface area are you talking about?
About a tennis court size,
yes.
If you strip it all out, so it's really huge. It's there's a huge amount of work that goes on in there.
And all this work requires a healthy blood supply. As I'm lying here digesting my steak and chips, a third of my body's blood is being diverted away from my extremities and towards the action in my guts.
There's certainly active noises down there.
And as this blood rushes through the vessels in the wall of my small intestine, it's picking up digested nutrients and transporting them all over my body. But this could take another 3 or 4 hours. So there's time for me to get more hands-on with another digestive system.
Ooh, yes.
Here we go.
That's a treat, isn't it?
Surgeon and gut specialist James Kinross has brought along the intestine of an animal that was destined for the food chain.
So what we have here, this is a pig, from mouth down to the anus at this end here.
Right, so this is the whole...
Although we don't look much like pigs on the outside, their intestines are remarkably similar to ours.
And what you can see is that the gastrointestinal tract is basically a tube, and it runs literally from your mouth all the way down to your bottom.
Okay.
So what you have is the esophagus at the top end. We can actually trace all of this bowel the whole way down.
The walls of the small intestine feel surprisingly delicate, and they are threaded with tiny capillaries.
And what you'll see is there's a layer of connective tissue.
Oh, yes.
So the bowel has this connective tissue which takes the blood supply, and you can see the blood supply here. So when you absorb a meal, obviously the nutrition that you take out of it has to get into the blood supply.
Yeah, and that's what's happening to me at the moment.
So let's see how long this is.
The human small intestine is roughly 4 meters, the length of this table.
Okay.
Oh, right.
A pig's is much longer.
Return journey.
Keep going, and keep going.
Our intestines absorb about 7 litres of food, fluid and gut secretions every day.
Isn't that majestic? Yeah.
But perhaps the most extraordinary thing about the intestine is that buried deep inside its tissue is a very thin layer of brain.
When you think about your brain, normally you think about the thing up there in your skull, but you actually have a second brain deep down in the gut. It's made up of cells like neurons, which you also find in your main brain. And in fact, there are over 100 million of them, as many as you would find in the brain of a cat.
The neurons are spread out in a thin mesh that extends all the way from the throat to the rectum. This brain in our gut orchestrates our digestion. It's also involved in gut pain. And surprisingly enough, the way we respond to pain seems to be linked to our personality type. I've got a personality test here which I've got to fill in, which could be dangerously revealing. It says a number of characteristics here may or may not apply to you, and I've got a score between 1 and 5 for each of these particular characteristics, where 1 means disagree strongly and 5 means agree strongly. So first up, is talkative. I think I do like talking. Give myself a 4. Agree a little. Tends to find fault with others. Nope, 2 on that. This test is designed to analyse the broad traits that make up the human personality. Is original. I'm going to give myself a 5 on that one. Of these traits, 2 have been strongly linked to the gut, being extrovert and being neurotic. Extroverts tend to be the life and soul of the party, whereas neurotics are quieter, more anxious, and often put a negative spin on events. Nope, no, I don't like quarrelling. Can be tense, yes, I can be tense. Sometimes not. Most people are predominantly one or the other. I think I'll give myself a 4 on that. 3, 5, 1, 4, not overly so. OK, that's complete. I'm going to send it off for analysis. Be interesting to see what they make of it. My test will be analysed at the Wingate Institute in London by gastroenterologist Dr Adam Farmer.
So what we're trying to do in this study is relate personality to pain responses and to try and link the two together.
Adam reckons that my personality will influence the way the neurons in my gut respond to pain he's about to inflict.
You just rest your arm there, just so you're nice and comfortable.
These findings are important because they could change the way doctors treat chronic gut pain. The test involves, once again, sticking a tube down my nose and into my gullet.
So once it's down and sat in your gullet around about there, then we'll inflate the balloon to cause pain.
Oh, God.
OK, here we go. So slight tickling at the back of your nose now.
Adam has found that the guts of extroverts and neurotics respond to pain in very different ways.
Well done. So the tube's down. You're quite safe now.
I may be safe, but I fear the worst is yet to come.
We're going to give you a series of 7 painful stimuli. I'm going to inflate the balloon up to your pain tolerance level. And what really I mean by that is to the point where you can't tolerate any more, where you've had enough.
You ready?
I'm ready. And you're ready?
I'm just about ready.
OK.
OK. Oh, yeah. OK. Unpleasantness at 7 to 8 and absolute pain about an 8. Oh, bloody horrible.
To see how my body responds to pain, Adam monitors my heart rate and blood pressure. I'm expecting them both to rise, because that's what the textbooks say.
So the pain's coming now.
Yeah! Yeah. I am keen for you to remove this thing now. So the results.
If Adam is right, my pain response will be determined by my personality type.
Your psychological results were extremely interesting. In terms of what do you feel your personality traits are? It's often a good suggestion.
Yeah, I think I'm probably inclined towards the neurotic. People, when they meet me, they assume I'm more extrovert, but actually I suspect I'm a neurotic, posing as an extrovert.
And absolutely, they were very much the results from your personality questionnaires that out of a possible 100 on the neuroticism scale, you scored 75.
Okay.
And as a neurotic, the changes in my heart rate and blood pressure were exactly what Adam expected.
So we can see that in response to the balloon, you actually dropped your blood pressure and slowed your heart rate down for a transient couple of seconds.
I find that really, really surprising, I must admit, because I would absolutely have expected them to go up. I've always been taught pain, basically, your heart rate goes up, your blood pressure goes up, your body doesn't like it.
It seems, however, that when neurotics are hurt, the vagus nerve, a nerve that connects your brain to your gut, becomes more active. This causes heart rate and blood pressure to drop, which in turn is believed to have a calming effect, reducing the amount of pain that's felt.
And you don't find that in extroverts?
No, extroverts tend to have the more classic heart rate goes up, blood pressure goes up.
For Adam, the results mean that neurotics and extroverts could be treated for gut pain in very different ways.
For instance, those who have high neuroticism scores, we would use psychological techniques such as cognitive behavioural therapy, whereas the more extrovert ones, we may well use pharmaceutical or drug therapy in these patients.
Brilliant. I have to say, I rarely go in for an experiment of some form where I'm genuinely surprised at the end, but I was genuinely surprised by this one.
Great. Well, you were an excellent subject and you did extremely well.
Thank you. Oh, yeah.
It's been almost 9 hours since I swallowed the camera and began life as a museum exhibit. During that time, the camera has travelled over 5 metres through my guts. But from now, things will really slow down and move along at an even more leisurely pace. We're at the outer reaches of this alien world, the large intestine, or colon.
You can see that the lining of the colon is very much flatter and whiter than the small bowel. And you can see the little blood vessels running through very, very clearly in colon.
Right.
So
very weird, isn't it?
It's a big organ, so you can often see a big hole, whereas a small bowel is very long, but very small in diameter.
Through the flatter, wider surfaces of the colon, water is being drawn out from what remains of my food.
You have some slightly more formed material in there.
That's Mark's polite way of saying that what we're looking at is feces. But it's not just leftover food. A third of the weight of my feces is actually bacteria. There are trillions of them, and they form their own mini ecosystem. They feed on the food that my small intestine wasn't able to digest, helpfully breaking it down into nutrients and also making vitamins. From their dark, dank home in the colon, these bacteria play a critical role in keeping us healthy. Most of us don't want to think too hard about feces, but I'm off to meet a scientist who's absolutely fascinated by it. And she claims that you can learn an awful lot about somebody simply by examining their excrement. Well, I've sent her a sample of my own, and I'm off now to discover just what she has learnt about me. Microbiologist Dr. Gemma Walton spends her professional life investigating the different bacteria that colonize our guts. It's important work, but her research does give her laboratory a very distinctive odour. Oh, God. Ah, that is... Hello, Gemma.
Hi there, nice to meet you.
I'm not sure I should shake hands. That is a truly revolting smell.
It's a lovely lab smell.
It's not a lab smell. It's the worst bathroom sort of pooey smell. Inside these flasks, Gemma has recreated the conditions found in the human colon. She uses this to study some of the huge variety of bacteria that live there. Each of us has our own unique mix of different strains, and Gemma has been looking at mine. First up, lactobacillus.
So lactobacillus is a big group of bacteria associated with some quite beneficial effects.
As well as helping break down food, lactobacillus excrete acid, which fights off other, more harmful bacteria.
So these are good guys.
So yes, these are your own good guys.
But she's also found some species that don't sound so friendly.
If you have a look at that plate there for me, Michael, do you see some pink colonies on there? Now, those pink colonies are likely to be E. coli.
Right. E. coli, I think of as food poisoning, infections of the urinary tract.
Well, E. coli are often associated with those events. However, there are many, many different strains of E. coli, so it's not necessarily something negative. In fact, I would be more surprised if I couldn't find any within your sample. So they're a perfectly normal part of the gut balance.
OK. Gemma reckons I have over 1,000 different strains of bacteria in my faeces. And fortunately, I have a healthy mix. But that balance can become upset, leading to diarrhea and irritable bowels. If that happens, the good guys may need help.
So there's two ways that you can do that. It's the prebiotic way. So the prebiotic is the food that you eat that then is a food for your bacteria. So that can help increase numbers of your beneficial bacteria. The other way is you can top up the good bacteria by consuming probiotic products that actually have their own live bacteria in, and you're introducing them into your gut by consuming them.
In some cases, that's not enough. Another lab and more feces. This time St Mark's Hospital in London. Gastroenterologist Dr Elsa Hart is working with colleagues from Imperial College on novel approaches to rebalancing gut bacteria. The most drastic of which involves performing a fecal transplant.
Hello there. Hello. Hello, Michael. So what's happening in here?
Well, we're just in the process of preparing a sample for a fecal transplant that we're doing as part of a research trial here.
In this pilot study, feces from a healthy donor are transplanted into the guts of patients suffering from a condition called pouchitis.
Pouchitis is a form of inflammatory bowel disease, and normally that's treated very simply with antibiotics, but in a small group of patients. When the antibiotics haven't worked, the next line of therapy becomes a little bit trickier, and it's in that group of patients that we're going to try this particular technique.
They are hoping to replace the unhealthy mix of bacteria in the patient's guts with a healthy mix of someone else's. First, the donor feces are blended with salt water and then filtered.
It sounds, I must admit, slightly revolting.
It does sound revolting, it sounds disgusting, but this is for a group of patients who have had a lot of therapies beforehand, troubled by lots of diarrhoea, awful incontinence, and really dreadful quality of life, actually.
The next stage is to put the fecal solution into the patient.
We take a nasogastric tube.
Down it goes, down the nose, presumably?
Down the nose, into the patient's stomach, and then it's simply, the syringe goes onto there and you put it down into the patient's stomach.
And it just goes straight into the stomach?
And it goes straight into the stomach.
Dr Hart is looking for signs that this radical approach will improve her patient's symptoms.
So by giving this transplant, are we able to alter the bacteria in the guts of these patients? And of course, is it having a clinical benefit in them as well?
It's early days, and so far only a handful of patients have taken part in the study.
It's the most densely populated ecosystem on Earth. So to try and understand it is a very tall order. To try and modulate it, you know, you do ask the question, are we as human beings clever enough to do this?
Back at the Science Museum, my food has been digested and absorbed. What's left has been chewed over by my gut bacteria and is now nearing the end of its journey. But feces are not the only thing that the bacteria in your gut produce.
Flatulence. All of us produce gas. I guess the question is, how much do we produce? Any guesses?
I would say about 7 times a day.
12 to 15.
100 times.
25, 30.
I always thought it was 13.
I haven't farted so far today.
You farted on the way here in the coat.
No, I didn't.
200, 20 or 30, 5.
5 times a day?
Yeah.
No, it's a lot more. 5,000.
Could be ones that you don't even notice, you know, involuntary.
In fact, we're letting out an average of 12 to 15 every day, typically releasing about 2 litres of gas.
I was looking to see what he had going on.
Fortunately, according to Gemma, not all of them are smelly.
Well, there's 2 types of flatulence. Some people have very odorous flatulence and some people less so.
If you have particularly unpleasant flatulence, blame the mix of bacteria in your colon. Some produce pungent hydrogen sulfide gas, others the less odorous but more flammable methane. And just as diet can affect the balance of good and bad bacteria, so it can alter the balance of sulfur to methane producers.
By changing your diet, you might actually increase the amounts of hydrogen sulfide produced if you were eating quite a sulfate-rich diet.
Which are the foods that actually produce the worst flavors?
It would be things like beer and wine, breads,
vegetables.
Vegetables? This is a reason not to eat vegetables.
So no, not at all. Flatus is actually a really, really healthy side effect of eating fibre in the diet. So it's something you really want to be doing.
Right, I thought I'd share with you, this is the essence, if you like, of really, really horrible flatulence. It's a sulfide group, and I thought that you would just be keen to have a little sniff.
Nice. Thank you.
What do you think?
Does anyone recognise the smell?
These are sulfides. No, not for you. That's really, really revolting, isn't it?
Maybe it was the smell that put them off. But it's late and the Science Museum is about to close. The day has certainly been eventful, and this alien world in my guts is a bit more familiar now.
But there's still quite a lot of gunge around there, isn't there?
Time for one more peek at what's going on inside me. And there's one last question on my mind. When's the camera going to come out? I know it will work its way out of my system, and that could happen sooner rather than later.
I think I need to go urgently to the loo. I will be back.
We'll see you shortly. That's good. It might come out yet.
Over the last 12 hours, as I've digested my food, my guts have been under intense scrutiny. They've been poked and prodded in more ways than I could have possibly imagined.
Oh, God, brings tears to your eyes. Yeah!
Along the way, I've discovered that what goes on inside this mess of tubing not only profoundly affects our health and well-being, but our behaviour too. My experience as a museum exhibit has left me with a huge respect for my guts and its inhabitants. They are working together with an intelligence and complexity that we're only just beginning to understand. And as for the camera, it did eventually find its way out. But that's one part of this process that I'm going to keep private.